Alright guys, so today we're going to continue our condensation and hydrolysis reactions that we started last time by learning how to synthesize and break apart an amide. So we'll start with the synthesis reaction. What two reactants do you think you must have to create an amide? So if you said an amine and a carboxylic acid, you would be correct. Okay, so let's talk about the actual reaction. So this is going to be a two-step process. The first step is going to be a neutralization reaction between our carboxylic acid and our amine. So this is a weak acid plus a weak base. In step 2, we're going to take the salt that results from that neutralization reaction and we're going to heat it. And that heat is going to drive out the water and produce our amide. Okay, let's give this a try. So here I have an amide synthesis reaction. I want you to start by naming the reactants. Then I want you to draw the salt product from our neutralization reaction. Then we're going to heat our salt product. And so then I want you to draw our final amide product and name your final amide product. So go ahead and pause this video and see if you can work through this reaction. Okay, so let's start by naming our reactants. So we have a 3-carbon carboxylic acid, and we have a 2-carbon amine. So the IUPAC names for these molecules should be propanoic acid and ethanamine. Okay, so now let's perform our acid-base neutralization reaction between our propanoic acid and our ethanamine. So propanoic acid is going to act as the acid. So it is going to donate a proton to ethanamine. So our resulting anion will look something like this, and our resulting cation will look something like this. And I didn't ask you this before you started, but you could name the salt, and we're going to name the salt just like any other, where we start with the cation name, which would be ethyl azanium. And we end with the anion name, which would be propanoate. Okay, so now let's heat our ethylazanium propanoate. So remember, when we heat this, we're going to drive out the water. All right, so we're going to circle on our ethylazanium propanoate where the water molecule came from. So the O is going to come from our propanoate, and the two H's are going to come from our ethylazanium. And we're just going to join everything that's left of our salt together to form an amide. So as always with either an amide or an ester, I'm going to start with the 3 atoms I know has to be there. So for an amide, we have to have a carbonyl attached to a nitrogen. And then from there, I'm just going to fill in the rest of the atoms. So we know we have 3 carbons on our carboxylic acid residue. And we have 2 carbons on our amine residue. And we should have 1 hydrogen left attached to our nitrogen. And remember, we have to put that in because hydrogens are only implied when they're attached to carbons. Okay, and so our IUPAC name for this molecule would be N-ethyl propanamide. Okay, so if we can synthesize an amide from a carboxylic acid and an amine, we should be able to break apart an amide back into its original carboxylic acid and amine components. And we're going to do that via a hydrolysis reaction, which, if you remember from our last lecture, is where we split a larger molecule into 2 simpler molecules by adding water. And for an amide, that's going to require heat and either an acid or a base. We can do this under acidic conditions or basic conditions. So let's try an example. So I want you to pause this video and see if you can draw a chemical reaction for the acid hydrolysis of N,N-dimethyl butanamide. I want you to draw the reaction, draw the products, and then name the organic products. So N,N-dimethyl butanamide. So butanamide tells us that our carboxylic acid residue has 4 carbons. Okay, and now our amine residue, the N,N-dimethyl, tells me that we have 2 methyl groups attached to our nitrogen. And since this is a hydrolysis reaction, we have to have water. And we're performing this under acidic conditions, so we need an acid and heat. Okay, so this is a hydrolysis reaction, and whenever I split up an ester or an amide via hydrolysis, I always like to start by drawing a little squiggly line between the carboxylic acid residue of our reactant and the amine residue of our reactant. Okay, so let's start with our carboxylic acid product. So a 4-carbon carboxylic acid should look like this. Okay, so let's work on our amine side. So we know that amines can act as weak organic bases. So that means they can accept a proton. And since this reaction is taking place under acidic conditions, there are protons everywhere. So our amine is definitely going to grab one of these protons. So our other organic product will be an ammonium ion. So an ammonium ion with 2 methyl groups coming off of it should look something like this. Okay, so now let's name our products. So our carboxylic acid, a 4-carbon carboxylic acid, would be butanoic acid. And our azanium ion with 2 methyl groups would be dimethylazanium. Okay, so now for homework, I want you to see if you can do this entire reaction again, but this time let's do a base hydrolysis. So I want you to draw a chemical reaction for the base hydrolysis of N,N-dimethylbutanamide, and we'll check your work next time to see how you did.